Welcome back to another real-time simulation video. Today we will create a real-time simulation of a boiler plant. We will use SQL Server to store the boiler information per second, and display the same in Power BI dashboard. Let's start with the SQL. In the SQL Server, create a new database. Enter a name for your database, and press OK. You can see your database in the Object Explorer. Next, right-click on the database, and create a new table. We will not create it using any query. We will import our data directly into the SQL Server database. And based on that data, SQL Server will create a table for us. Go to the Tasks, and click on the Import Flat File menu item. In the Import Flat File window, enter the location of your flat file. And press the Next button. If the data is correctly loaded in the Preview window, press Next. Review the data types, and press Next. View the summary and press Next again. If everything works fine and operation completes successfully, close the window. Refresh your database, and now you can see your table in the Tables area. View the top 1000 rows to verify the table and data. As you can see, the table is OK, and the data seems OK too. Now, open a new query. The query you are viewing on your screen will create a blank table, containing all the columns of our boiler table. To do this, we will select all into a new table, from our old table. But we will use a condition that will not return any data. Therefore, the new table will contain all the columns, but no data. We can view the table, to verify that the table has been created correctly. As you can see, the table has no data, but it has all the original columns. Refresh the database in the Object Explorer, to view the table. You can also view the columns here. We can use the Insert command, to insert data, from main table, to this blank table. This is how we will simulate the boiler real-time monitoring. Instead of reading data from an actual boiler, we will read each row, from the main table, and store it in this table. Here is the row we inserted. Let's delete all the data from simulation, every time the simulation is started. A variable must be declared, to keep count of rows. We will create a loop which will end at 1999, which are the total records, in our main table. We will add a break of 1 second in our loop. Due to this break, every row will be updated after 1 second. In each iteration, the variable I will be updated, increased by 1 number. This variable will be used in the Insert command, in the where condition as row number. So in the next iteration, the next row will be inserted. Finally, we will add an Insert command, which will copy 1 row from the main table, after each second. The Insert command will insert data from the main table, into this table, 1 row per iteration. In the where condition, we will use the variable I, which increases by 1, after each iteration. Due to this, in every iteration, the next row will be copied. Because the time column is a series of numbers, so the row where time equals the variable I, will be copied. Because the time column starts at 1. We can either set the initial value of I as 1, or move the set command above the insert command. To test the code, temporarily we can add a select command here. Let's test the code now. The code works fine. It perfectly simulates the readings from a boiler per second. We can delete the select command now. Use the get data to connect to the SQL Server database. Enter the name of the server in the SQL Server window. You can get the name of the server from SQL Server Management Studio. Copy this name to the SQL Server name field. Enter the name of the database. Remember to select Direct Query if you want real-time data. Press OK and wait for Power BI to connect to the server. In the Navigator window, select the boiler table, and press Load button. Wait for Power BI to load data. Once the data is loaded, all the fields will be available on the data pane at right side, for you to create visuals. Start your dashboard by adding a text box visual. Enter an appropriate title for your dashboard. Change the font size to make it prominent. Place it at the top of the screen. Make it bold as well. Add the water flow rate filed to your dashboard as gauge visual. Place it at the top left corner. Enter the title of the sensor, which is water flow rate. Add time field as filter to the gauge visual. Select top N as filter type. In the show items, enter 1. In the by value field, enter the time field again. Apply the filter now. Check the minimum and maximum values of this sensor. Now, add a new measure for minimum value. Add another measure for maximum value. Now place these measure in minimum and maximum value fields. Let's turn on the page refresh and set the refresh interval to 1 second. Now, let's go to the SQL Server Management Studio and execute the query. Now we can go back to the Power BI and see if the simulation is working or not. It seems that the query is working. Make a duplicate of the gauge visual. Replace the flow field with the gas consumption field. And change the title of the field. Check the maximum value of the sensor. Based on this maximum value, create a new measure. Replace the previous maximum with new measure. Again, make a copy of a gauge visual. Replace the gas consumption field with the return water temperature field. Change the title of the field. It is better to add unit as well. Check the minimum and maximum values of this sensor. Accordingly, create measures, and replace the minimum and maximum fields. Create another gauge visual, using one of the existing visuals. Replace the value field with the supply water temperature field. As usual, check the minimum and maximum values, and make adjustments accordingly. Create another gauge visual. Add the power consumption field to the value area. Change the title of the field. Check the minimum and maximum values, and accordingly change the values in the gauge. Finally, create another gauge visual for hot water loop speed. Change the title of the field. The maximum value of this sensor can be 1. Create a measure for its maximum value. Add a line chart to your dashboard. Add the hot water loop differential field to the y-axis. Change the title of the field. Add the time field to the x-axis and to the filters as well. Set the top end to 30 using time field. Apply the filter. Add another line chart using the existing line chart. Replace the y-axis with hot water loop supply water field. Change the title of the field. Add another line chart for hot water loop, return and supply water temperatures. Change the title of the fields. Add a line chart to display outdoor air temperature. Add the outdoor air field to the y-axis. Change the title of the field. Finally, add another line chart to display secondary power in kilowatts. Add the secondary power field to the y-axis. Change the title of the field. Our dashboard is now complete. For our final visual, we will add the time field to the dashboard as a card. Place the card at the top right corner of the dashboard. Your dashboard is now complete. Turn the page refresh on, and run the query, to see the real-time simulation. Thanks for watching. We hope you liked our tutorial. Don't forget to like and subscribe for more tutorials and updates. You can ask any question, or leave feedback in the comment section.